Hi, this is Tamdir Podcast, Innovation at the Edge with Open Source. Today, we catch up with the latest technologies in embedded space for NVIDIA products and a few more with our guest today, Matt Madison. He's a longtime maintainer for Yocto VSP for NVIDIA embedded modules. So, um, welcome back, Matt.
Yeah, good to be back. Good to be talking to you guys again.
Hi, Cliff. How are you doing?
Yeah, great to be here, and again, nice chatting with Matt again. Look forward to this.
Yeah, I think we had a lot of fun last time, so I'm, um, hoping to carry on. And so, for our new listeners, Matt, could you talk about, what you have, what have brought you here so far, and what are some of the cool stuffs that you've done in your career?
Well, okay, sure. I've been doing software for a long time. I started out working on time sharing systems. Those room-sized computers that people laugh at these days. And I was involved pretty early on with what was known as freeware at the time, back before it was called open source, where you give away software. I had some software that I'd written for some digital equipment corporation systems that back just as the internet was dawning, would connect internet email to other email systems, because there were other networks out there besides the internet, and that got me some notice in that community, and got offered a job out in California to work for a company out here that did TCP/IP networking for VMS systems. That company then, some years later, got acquired by one of the large networking equipment manufacturers in the Valley. Worked for them for a long time. Got involved with embedded Linux while I was there. Started that around 2010, working with the Yocto project tooling. And then it's been embedded Linux ever since then, and a variety of companies, teaching them how to use Yocto project and adapting Yocto project tools to building systems for Freescale, NVIDIA, and now Rockchip devices.
Mm-hmm.
And others.
Yeah, it's been about 15 years. That's a long time. Yeah. When did you get started with Yocto or Open Embedded Camp? Do you remember?
2004, something like that.
Yeah.
So,
it's pretty much at the beginning.
Yeah. With those sharp Zoruses,
Mm-hmm.
Right. It's got a long way since then. I mean, the Open Embedded project and with the Yocto project, it doesn't look anything like it did back even in 2010.
Absolutely, yeah. I think so many requirements that came from different sectors. It has kind of gradually transformed itself. Like, you're right. Like, if you compare 10 years ago, 15 years ago, it's nothing like that. But gradually, it has become, and hopefully useful for a lot of folks that are looking to solve problems around embedded systems today.
Yeah, especially if you need to do it in a real, I would say, professional, scalable way. I mean, there's been a lot of features added to the tooling to share more build artifacts across multiple builds, to do tracking of what's in your builds, all the work around SPDX and SBOM. That's been coming in recently, to deal with the new languages that we're having to contend with, whether it's Go or Rust, or it's been great. It's evolved over time to really be a useful tool for embedded systems. I'm really happy with it.
Yeah, and I think you were the one who did the Go port, if I remember.
That's right. I did.
And
had a need at the
and
time.
thanks for doing that, because I was basically so helped with it. I brought it to the core, and then it has been there ever since. Um, but I think you're right about the programming paradigms coming along. There have been challenges for sure. Given the managed runtimes, or the module ecosystems that every language has these days. Yeah, sometimes steps over the distributions. What they do in terms of their functionalities. So there is always a tension, probably a healthier one, amongst them about who packages what and who builds what. Um,
Yeah, and that affects the major distros for desktops and servers too. I mean, I know there's been lots of arguing around in Debian and Red Hat for Fedora about how best to slice that between the traditional distro approach of packaging versus what these new languages are expecting. I'm not sure there's a really good answer yet.
yeah, and I think I do understand the argument from both ends. So yeah, it's interesting conundrum to solve, and uh, in the end, I think the fundamental requirements are very similar to both of them. It's just that there is probably less tooling that is common, and one has done it before the others. So there is always that bias that comes in. So, but there's good things about Go, good things about Rust, good things about npm packaging, so to speak. I think they have served their purpose. The amount of uh, community that grew uh, speaks for it, right? And the scale that they address, perhaps, and
Yeah,
generate a lot of reuse, for sure. We do simple IT project, and it's written in Go, and Cliff would talk to it like how much module reuse, it happens because it's written in Go.
yeah. I think that's for us in the embedded space. It's the problem is that you're not always targeting a system that is going to be going to have the connectivity that's kind of assumed by the packaging, whether it's npm
Yeah.
or even Go or Rust. You don't. We tend to want to be very controlling of the sources we use, and make sure that we have them archived so that we can reproduce builds. And this whole idea of, well, when you fire up the tool chain to start the build, it just goes and fetches all this stuff over the internet, and then you've got yourself a program. That doesn't fit well with the traditional mold for embedded builds, at least not in my book.
Yeah. Yeah, I think if think of maintaining it over a period of time, you definitely need that control, because once you distribute components, you have to you also have obligations for distributions, being a distributor. So certainly you cannot rely upon like fetching right then and there when you compile it. So yeah, I think all that infrastructure definitely needs to be there, so you can kind of reproduce it, rebuild it at any time, as long as it is maintained, and produce exactly the same bits if you haven't made changes. So certainly, I think that's a requirement. I guess from a developer's perspective, that may not be as appealing. They would like latest and greatest, and they would definitely love to reuse the latest stuff from you, and then develop on top of that. That makes sense too.
Yeah, sure.
So we spoke about several things last time. So what have you been up to since then?
So yeah, well, in my day job, my most of my time's been spent on a new project that's where we've moved away from using NVIDIA, like we did on our original product, to the ROT chip family of SoCs. That's been an interesting learning experience. The Rock chips are actually pretty nice chips, I think. At least the latest generation, I would say, the 35 8X, 35 6X family. They're pretty capable, and they're relatively inexpensive, which is always a plus. I've been trying to get those corralled into our Yocto build system, which has been a bit of a problem because the Rockchip BSP isn't. Rockchip doesn't really publish one that's generally available. You get it if you're a customer of theirs, but you tend not to. You tend to get it through the distributor that you're getting it from. It's not, or the module manufacturer that you're working with. So it's not always readily available, and it's not as well organized as some. But there is a meta Rockchip layer. There's actually a meta Rockchip layer, multiple meta Rockchip layers. There's one that's hosted, I think, still at the on the Yocto project Git server. That's kind of focused on upstream support for Rockchip. But there is a guy who's a Rockchip employee, I believe, that has his own meta Rockchip that's essentially a copy of what Rockchip uses internally for their own Yocto builds. Unfortunately, it's not really usable as a BSP layer. It takes a lot of shortcuts. It's fine for their testing, but it's not something you can really use for a product. So I've tried to take a middle road and put together a layer that uses the downstream Rockchip kernel and drivers and so forth, so that you can use the features on the chip, much like I did with the Tegras when I started out there. But at the same time, try to make it a usable layer for actually building real products and have it behave like a real Yocto layer that will play well with others. So I do have in my own GitHub, I do have a copy of that. I got that out in the open, and I've had a couple of people look at it and ask me questions about it. But it's still a work in progress that hopefully I'll be able to do something with once I get past some milestones at work.
Yeah, that's awesome. I've played with some of the rock chips. I still have some lying around here, and I think you kind of like pin the problem right. Like you have one area where you get all the features on the SoC that you can enable, but that BSP is either old, supporting some old releases, or isn't functional, or is probably provided by the module provider. And then the upstream on Yocto project has latest and greatest from upstreams, but may not have all the features. So I think this is a typical problem. So I'm really looking forward to if you publish this layer, which is kind of a combination of both, and is really usable at a product. And then you can kind of like have all those nitty-gritty codecs and everything working. So are there any specific SoCs that you're working, or are they like something you can work with the Rockchip and say work with them on publishing and supporting the layer, or have you kind of like thought in that direction?
I haven't tried reaching out to Rockchip to see if they'd be interested in this. They're kind of remote, and it's not sure how easy that would be. But I'll keep working at this, and if an opportunity presents itself, that would be great to make that happen with their help. It's just from my read of the way they do present the BSP, it's like any chip manufacturer. They're interested in making the chips work.
Yep.
I think their primary focus is Android, or has been, because these chips get used in Android products. And the Yocto stuff is kind of an alternate. They do have I guess they provide a Debian build too in their BSP. Though
Yeah.
and they kind of share some infrastructure across those. It's just kind of hard to make sense of it's not organized in a way that makes it abundantly clear how to move from one to the other, or what the right way to do this, other than if you're trying to get a product built, you can use the BSP as it is, get your build done, okay, and then you're done. But there's not a whole lot in there around that would lead you down a good path for maintaining it over time, and dealing with upgrades and things like that. That if you're building a product, you got to think about, right? So it's but they're focused on selling the hardware and getting you to upgrade to the next version of the chip when that comes out and stuff like that. That's just the way the chip manufacturers are. And so it's the old problem.
Yeah.
Especially in the consumer space, they don't really put as much thought into what makes a good BSP, which is one of our main topics in our last discussion. Was we had some good thoughts shared on what makes a good Yocto BSP. And we're hearing again of some of the problems in our industry where chip manufacturers don't really get that yet. So,
in consumer space, the typical expected life cycle of a product is a couple of years, maybe. And for a lot of these embedded products, I know in my space, we're looking at 5 to 7 years at a minimum. The sales cycles are pretty slow in some of these embedded product spaces, and it could be 10 plus years, and that's a long time to be supporting some of these things. A lot longer than some of the chip vendors think about.
Yeah, and there is the CRA coming along in Europe, and that is definitely going to be something interesting to watch out for in terms of life cycles. And you're right, a lot of times all these consumer products, they kind of create a release, and then they just live with that release, never thinking of upgrading or moving kernel to a newer version or anything like that. So newer chip comes out that may have a newer kernel, but it doesn't support the chip that you might have put into your product that is to be supported for 7 years or something like that. So you're stuck there in that maintenance problem. And
it's not like some of the smaller embedded chips where the operating system, whether it's Zephyr or FreeRTOS or whatever, it's not that it's not an important part of the system. It's just it can be relatively fixed over time. Whereas Linux is an ecosystem all by itself, right? It's not like it's just the kernel and the drivers. Even the kernel isn't just the kernel. It's got contributions from hundreds of people from hundreds of companies, and it is continually evolving, and they're continually finding security flaws and things that need to be patched. But then you build on top of that, you've got a collection of software from a wide variety of sources that all need to be integrated, and it's just not. And your actual application is just that you might be running on the device is just one piece out of hundreds that go into building it. Yeah. So you can't. It's like the microcontroller stuff that my colleague at work works with. It's mostly his code, and the operating system is just this little teeny sliver of that.
Right.
It's just not the same with these bigger devices.
Yeah, I mean, for Linux, embedded Linux systems, I think you'll see it's like tip of iceberg, right? What you develop on top is just the tip. There's this huge iceberg underneath, which is called the embedded Linux. That is sitting on top.
The tip is the really important part, of course, right, from a product perspective. But the rest of it is important to be thinking about
Mhm.
if you're designing and maintaining these things.
Yeah.
Yeah. And now that
It will.
every system is connected, it becomes even more important.
Yeah. One thing is I've been doing some work with Zephyr, and they've really done a nice job of pulling in all the different chip vendors' house into one cohesive build system. And they must have some standards, like if you're a microcontroller vendor and you want your HAL to be listed in the West manifest, so that's automatically just available to people using Zephyr. There's probably certain standards. And it just seems like it'd be really nice if Yocto could get to that point where chip vendors would be motivated to raise the bar to a certain quality level if you want to be listed in the Yocto manifest, as one of the supported BSP layers. I don't know. It seems like that's the only way we're going to get to the point where BSPs are quality, if we have them kind of in a cohesive system. But anyway, that's just my opinion. It may not be reality, but
I think it'd be great. I think it's just a big jump and a big investment on whether it's the chip vendor's part or whoever to actually make that happen.
Yeah,
because it's just doing the meta-tegra layer, of which it's not as much a part of my day job as it used to be, but I still spend a lot of time on it, and so do the other folks in the community to try to keep that maintained. It's it definitely would require investment on their part, and I don't know, somebody would have to make a good value proposition to them to say, this is the benefit you get, you be by participating in this and making this investment and trying to make these better. Because I think based on all the bad mouthing that the ESP layers get in our community, it's I think if a vendor did go and do that, they would get might actually get them more business, maybe. Depends on how the companies that develop the products that might make use of it. It depends on how much they listen to their software guys.
Yeah. Anybody who's been through this cycle once, the next time they look very carefully at the BSP quality before picking a chip. So, you don't always have control over that, but anybody with any experience at all, that's going to be a primary consideration. So it seems like it would have to matter some, but maybe for the consumer space, you just throw bodies at it and you don't really care. But
so we've been talking about meta-tegra. So what's new in OE4T project?
Yeah, since last time, I think the new thing, we've had at least a couple of revisions of the Jetpack, the L4T BSP. I'm not sure if 36.4 was out last time or not, but that's a big change. That's Orin only, the Orin models only. They retired the Xaviers. They have done some maintenance releases for the R35 series BSP that still supports the Xaviers. And just within the last couple of weeks, NVIDIA did drop some information about the upcoming Jetson Thor processors that are due out any day now. They're always pretty cagey about what the release dates actually are, but they did publish some data sheets and other specifications. It's in the NVIDIA developer forum, not the developer forum, but their developer download site. So you can look at the hardware, and I would expect to see some kind of BSP out for the Thor sometime in the near future. Don't have any inside information about that, but if they go with their usual cadence, probably within the next month or two, I would expect to see something for software, so you can actually, and some development kits, so you can actually do some development work on the Thor. So we'll see how clean that is. It usually takes them a couple of iterations before it's really clean enough to be usable for a product, but at least it'll give us an opportunity to do some development work on the new hardware, so that maybe a year from now somebody could actually produce a product based off that. So that's all new. The other thing that we just had a recent, we've had this meta-tegra community layer for hosting recipes that aren't really part of the BSP, but might be of interest to folks that use the Jetsons. And it's kind of a hodgepodge. It's not as well maintained as the BSP layer itself, just because I don't have the resources to do that. But it's got a lot of useful stuff. But we just had a big dump of additional recipes for doing machine learning things like PyTorch that went in, along with recipes for the open source bits of the NVIDIA Holoscan SDK. So we have a community member who actually works on the Holoscan team in NVIDIA, and they've been working with us to get that stuff integrated, and they promise they will actually maintain those recipes. So I'm hoping that will hold up over time. I'm a little bit worried because there's quite a bit of stuff that's gone in, and I'm a little bit worried about how well that will, whether that will start to decay as time goes on. But still, there's some recipes that we've had a lot of people ask about in terms of, PyTorch and related machine learning tools that I know there's been some attempts at various times in the broader Yocto community to have recipes for that stuff, but I don't think there is any one place where it's really maintained across it, partly because to make use of them, you've got to have some kind of compute engine, and there's still a lot of fragmentation in that space. There isn't a single way to approach that problem. But yeah, so we've got something that at least folks that are using the Jetsons, and maybe even if they were using discrete NVIDIA GPUs, they might find those recipes useful. So folks could take a look at that too.
So what does Holoscan SDK do? Could you talk to that a little bit?
I'm not the right person to ask, but my understanding is that it came out of some products that NVIDIA were putting together an SDK. It was an SDK that they put together. I think it was mainly targeting medical applications. I think maybe it's expanded into other areas as well, but I just had a little demo this morning, and it's definitely some medical applications, because it was medical type pictures like ultrasound, sonograms on display and things like that. So you can do processing on the images that they get gathered by your medical imaging tools, that kind of thing. And I'm sure there's other uses for it as well. But at the bottom of it, the underlying tools you need to actually make the AI stuff happen are pretty much the same, I think, across different application spaces.
I see.
So I think Holoscan was just originally intended to be a sort of a vertical. And I think maybe it was considered special too, and don't quote me on this, but I think partly because of the safety considerations for medical equipment, that you have to do things in a particular way to be compliant for in the medical space. So I think there's some aspects of that too that were in the Holoscan SDK.
And there's some activity around secure flashing as well, I guess. So that's recent enough. So we've had secure flashing for earlier generations of Jetsons,
mainly because I needed them on my products, and so I got the tooling in place to do that. For the Orins, it's been a bit more of a challenge. I haven't had a driving need, so I haven't been able to spend as much time on it. But you can do it now with the Orins and the R35 or R36 series tooling, BSP tooling. One recent addition in 36 that's coming in 36.4.4, which we haven't integrated yet. We're still working on getting that integrated. Is they added support for storing your keys in an HSM rather than just in files. The flashing tools, I've always just assumed that you store your keys in files someplace, and that's how you use them. So they actually added support. NVIDIA added support in their the Tegra signing Python scripts to fetch that stuff out of using PKCS11, I think, out of an HSM.
So just a few definitions. What do you mean by secure flashing?
Oh, so secure boot, using secure boot, and so assigning the binaries, of which these days there are many, and then and doing that in a secure way. So I think that's probably the more accurate term, is more secure signing than secure flashing, and then just getting the flashing, getting the secure boot fuses burned. That I still recommend people use the straight L4T BSP to actually generate the fuse burning script that you use. NVIDIA has a mechanism where where if you work directly with an NVIDIA representative, they can actually even do an extra level of security in the fusing process that some customers might need. I don't know a whole lot about that, but just getting the basic fusing done, so that when the device comes up, you can't even talk to it unless you've got signed binaries in place. You can't even talk to it over the USB to do any flashing or anything like that. And then it's that process. It's then taking those signed binaries and downloading them onto your fused device. So I guess some of that stuff got worked out over the last year that had kind of been there from earlier revs, but wasn't quite up to date with the latest tooling and the latest changes in the BSP and the Orin changes, because this is one area where chip vendors do make seemingly arbitrary changes with every generation of their product, usually for the better. So,
So the application is just ensuring that your software is running on it, not some hacked version or malicious version or whatever.
That's right.
Like for a critical medical device or something like that.
Or even for ordinary other devices, the amount of they support both signed boot firmware and encryption.
Okay.
And then that also ties in with you can link that in with more general purpose encryption that you might want to use for other functions, like you could encrypt your kernel image, for instance, if you wanted to. And there's a whole secure boot chain that leads up to now the UEFI bootloader. And then UEFI has its own mechanisms for doing secure boot of the kernel, but NVIDIA's added some extra stuff there for if you want to do the encryption based off their encryption processor, using keys that you programmed with the boot firmware, using the secure boot flashing process. It's complicated stuff.
Yeah. So what's an HSM versus a flash?
So an HSM is actually, what is it? Hardware security module, I think is what it actually stands for.
Mm-hmm.
So it's basically a secure enclave that you have attached to your to the station where you're doing your builds, that you interact with, that holds the keys that you use for signing, and is not and is only accessible by you. So.
So is this a chip you'd put on the baseboard, or do the NVIDIA modules have these?
So for signing, this would be something that would be on that you would put in your workstation or on your server.
So it's not actually on the target.
No.
Right.
The
Okay.
targets have their own facilities for handling the secure boot process, but the signing process, it's just a way of having a way to have your signing keys secured against leakage to people who shouldn't have them.
Right. Okay.
Yeah, so I think these are very specific use cases, I guess. So I know the meta-tegra is like very well maintained. Given all the complexities that we talked about, it kind of like brings forward to the users. So what are some of the use cases for OE4T?
Well, yeah. What do you want it to do? You can use it for anything. It's a floor wax and a dessert topping. Now, if you actually get that reference, I'd be surprised. I think it really could be. It could be used for anything, place where you need the Jetson processor, or some combination of a CPU and a GPU, where the Jetson might be a good choice for that. You could use it. What I find is that most of the people that use it, that I hear about anyway, tend to be using it for machine learning, AI, at the edge. So it's typically running models, not necessarily populating them, but running applications that make use of machine learning models. I know our own the products that I work on have been mostly computer vision based. I know some other folks in the community that do computer vision processing too, but also just more intelligent machinery of any kind, or robotics type applications. There's plenty of graphics horsepower in these things too, and we have the drivers there for that, and you can do that. But I don't get a whole lot of requests for getting Chrome to run, a Chromium browser to run. And maybe it's just because that's not my interest, and there are people doing that, and it just happens elsewhere. But I haven't had to do. I think we've got some folks that use Qt toolkit, and they've got a system for doing that using the Jetsons with Wayland, and that works for them. So if they need to drive a display or something, for interactive purposes like a kiosk or a control panel, that works out fine. But I think it gets more use than I can actually have visibility into. Like you guys, I don't do a whole lot of tracking. GitHub has some statistics on how many clones there have been and how many visitors we've had, and it has certainly grown over the years. We get thousands of cloners a month now, where it used to be a few hundred. So I think it's pretty widely used. And some of the information I get secondhand is from folks. I have heard that even NVIDIA knows that there are a lot more users of this than of Jetson Linux in certain spaces, just because Yocto is well established in the embedded community, and like the company, some of the companies I work for, and other companies I've heard of that started out using Jetson Linux, the Ubuntu stuff on a product, they didn't repeat that mistake on the second product they did, and for the Yocto, just because like we talked about last time, Ubuntu isn't a great solution for an embedded system.
Well, that's very interesting, actually. I think, from your experiences so far, I guess, that reproducibility and processes to build it and build it in a repeatable manner, I guess, goes a long way.
Yeah.
There was discussions around bring your own kernel, and so where is it? Like, do we have an upstream kernel now in meta-tegra?
Yeah, actually, you can. You can use and in fact, we use Linux Yocto and do a BB append on that and do a bit of configuration of it. And you can use that in our master branch. I actually build that on a regular basis. It's a little bit of a challenge. It's not entirely stable right now because with the R36 series of the BSP, also known as Jetpack 6, NVIDIA did restructure the way they did their kernel. They used to combine all of their proprietary, their own downstream drivers. I won't say proprietary because the source is there. Downstream drivers into sort of sitting alongside and as part of the kernel build with the main kernel. With Jetpack 6, the R36 series, they've switched to actually the kernel is done by Canonical Ubuntu. It's actually it's one of their kernels. They do kernels for specific vendors, but it does not have any of the interesting drivers for driving the interesting hardware. All of that's handled out of tree. So there's a separate recipe now that we have for building the out of tree drivers. The sources are provided in the BSP. They also have them in NVIDIA's Git repositories. If you want to use them, the structure is a little bit funky, but so the display drivers there, the for the GPU, the display controller, and then all the other special drivers. But the way the out of tree drivers are structured, they try to make the drivers compatible with a number of different Linux versions, primarily to support this bring your own kernel approach. But the latest kernel that they'd been working with, from what I can see in the scripts that they use to configure this stuff, is maybe around 6.8. So in Yocto, in OE Core Master, we're up to Linux Yocto 6.12.
Yeah.
So we've had to do some additional patches on top of the NVIDIA out of tree drivers, and that means that if anybody wanted to actually take the 6.12 kernel and try to use it in a product, I would recommend being careful about that. But back in the LTS Skarthgap branch, I think we're still at 6.6 or 6.8 for Linux Yocto. So I know that we've got some folks in the community are actually actively using the Linux Yocto kernel with the NVIDIA out of tree drivers on their Jetson-based products. So it is an improvement over where things were. It was really hard to take the 5.10 was the last version of the kernel and try to update that without messing up something in the kernel build because of changes that NVIDIA had made across the tree and not just in their own space. So the out of tree drivers do make that situation a little better, but this configuration scheme they have for trying to adapt to different kernel versions isn't the easiest thing to understand.
Yeah, it smells like what Android has, like Android Common Kernel and Kernel Module Interface, the GKI initiative. I think.
Right.
Kind of a variant of that, I guess, or at least the problem is same.
Yep, exactly.
Pretty cool.
So yeah, that is another new thing though that's come up in the last year, which is people see as a plus. I do. The more NVIDIA can actually upstream this stuff and the less of the hopefully the out of tree driver
concept
package will get smaller over time as more and more stuff makes it upstream. But then they'll come out with another generation of chip, and there'll be a whole new pile of out of tree stuff. So I don't know. It's hard to get off the hamster wheel.
Mm-hmm.
Cool. So what are some of technologies that you're kind of like interested in nowadays?
Oh, well, one thing I've been spending a little time with recently, because this is something that's that we might use at work, is ultra wideband. Yes, it was a new thing to me when it first came up. I had to do a little research on it, but yeah, another wireless technology, of course. But interesting thing about being able to do ranging and distance measurements, and so you can, if you've got a couple of cooperating ultra wideband endpoints, you can. I guess it's the underlying technology used in like things like AirTags. So so you can use it for locating things. It's still pretty new and pretty complicated. I guess the automotive industry is looking at using it for car keys, things like that. So it's something I'm going to be playing around with here in the near future. I've been doing a lot of stuff lately with voice over IP, because we have an intercom on this product that we just put out at work, and I was aware of voice over IP technologies because I am an old guy, and a lot of this stuff was developed back in the 90s, and man, it still looks it, doesn't it? The protocols are amazingly ancient, but and it's hard to get them all working right. But that's been kind of interesting. And audio on Linux, which is also an interesting kind of a mess of different stacks and different capabilities, and it's complicated. So I tend to be a generalist. I like looking at lots of different things. Some of this stuff, I think you need to develop enough expertise that you can to be able to do it well, and audio might be one of those things. The other thing I've been playing around, I have my AMD Threadripper based workstation I've been using for the last 4 or 5 years now, and it's probably I'm be looking at building a new one. So I was thinking maybe now's the time to actually make the switch away from x86 altogether and go to something, go to ARM 64 or something like that. I don't know. What do you guys think about desktop or workstation use for non-x86?
Yeah, we have a thread on our Tempter forum about ARM-based workstations. So we've tried to collect things as we see them over time. So you might want to check that out. But you're probably more up to date, so feel free to contribute anything you find. I don't know. One thing that interests me is like the new mini PC form factor. Where you can get like a 12-core AMD, couple NVMe drives in it, all in a little box, like your mini Mac Mini there sitting there. So I don't know, that seems neat.
Yeah, my home built. I built myself the PC I'm using now, and it's this big box, and I made sure it had lots of cooling and stuff. But it would be nice to have something more compact like that. If I can actually run like Yocto builds that don't take and have them not take multiple hours to complete.
Yeah,
I have a Threadripper too, so it's been a great machine, but yeah, it's getting pretty old too. So
yeah, I think mine builder is in the same realm. It's probably 10 years old now. I've upgraded DDR on it, so it's been holding on, but probably I should look at rebuilding something. And I think the ARM based, I think there's a System 76 has kind of released one desktop lately, the Palia series. You want to look at that. It's pretty neat. The numbers look good, but I don't know. don't have first-hand experience of using it, but I think they're right there now, in terms of.
Yeah, the only thing that concerns me a bit is about some of the tools that, because we still use tools that maybe were written for x86 and kind of work in translation on the ARMs, but maybe they don't. It'd be my only concern, I think, on making a switch like that.
Yeah, I think one reason why we are not able to use, one of our, AGX system as our default in CI is exactly that, because our CI server is an ARM server, and there are certain tools that don't work with them. I kind of like use the QEMU user mode hack in there, with bin FMT, so that sort of works, but then it kind of falls into some other issues as well. So it won't be a smoother ride for sure. But
yeah. Do we still have problems building NXP machines on the ARM CI?
we do.
So that's still an issue.
Yeah, because they use pre-built tool chains to build FreeRTOS based, stuff in there, and those are targeted at x86 64.
Yeah. I guess they should be using Zephyr.
Yeah, or at least like tools that are compiled, not like pre-built blobs, because they lock you hard. Sometimes you can't even move from one distribution to another because, these tools might need some older version of libstrit++ or whatever, and you get stuck to Ubuntu 12.04 or something.
Yeah.
A true story, by the way. But cool. So what's your daily drivers, like any Linux distribution tooling or any other editors, etc., that you use?
It's pretty simple, really. I'm given my history, I'm still a terminal window guy. So any system that lets me have some terminal windows up is good. I tend to use Ubuntu. I'm up at like 24.04 now. I tend not to stay on the bleeding edge because I do need my environment to be reasonably stable. But it's fine. I'd probably be just as happy with one of the other major distros, but NVIDIA used Ubuntu for, pretty much required it for their SDK initially when they first put out Jetpack. And I think that was probably the reason I picked it in the first place. Plus, it's pretty easy to get set up with, and it supports a pretty wide range of desktop systems. So it's been fine. I tend to use Emacs for my editor, and that's a historical thing too, because Emacs was one of the only editors that I could use on. This was before I was using Unix systems, so because it had been ported to other systems that I was using at the time. So I've known it for a long time. I use the JetBrains IDEs for like PyCharm and CLion. Those have been pretty good for me. A little irritated at some of the, everything. Everybody wants you to use their AI stuff, and they can't. It's like, yeah, I know you've got AI stuff. Just get out of my way and let me get my work done. Stop harassing me about the AI stuff. When I want it, I'll ask for it. But but otherwise, they've been pretty good tools. That I can do. I can install a Yocto SDK that I built. I can point CLion at the environment script and have it run that, and I can set up my cross builds right within the IDE, which is kind of handy for development. That was something that they added a year or two ago, and it's pretty good at handling C and C++ code.
So that you use for application development, is it?
Yeah, okay. Yeah, because I've actually been doing some of that for a change.
Pretty neat.
But otherwise, yeah, I keep it pretty simple. In terms of things like the builds that I do that I maintain for the layer, I have AWS account, and I've got the build bot that I've got for the OE14 auto builder that runs in an AWS instance. Pretty small, and then I use my build bot adaptation handles doing searches for spot instances. So I try to keep my builds cheap by looking at the cheapest spot instance I can grab of a certain class for each time I do a build. So I try to grab something where I can get a discount on how much it will cost per hour. And that's worked pretty good. I can keep my AWS bills. I can keep under $100 a month. That way, at the expense of sometimes builds fail because the instance gets taken away in the middle of it. But I store all the shared state in S3, and it's populated out as the build proceeds. So when the instance comes back again to start the build again, it can pick up where it left off.
I see.
It's pretty stateless, the actual build VMs themselves.
So how do you map shared state to S3? Is that through some file system type thing, or? No.
I have a modified version of the S3 fetcher that BitBake uses.
So BitBake supports it.
Yeah, right. BitBake supports S3, but it does so through the AWS command line, which is really slow because you can't really use it for S-state fetching because it has to create a new session to S3 with each invocation of the AWS command. So I wrote a drop-in replacement for that maintains the security context and the session for accessing S3. It uses the AWS SDK to do that, Python SDK, and then it just makes the call. So you're not having to reestablish the security context with every fetch, and it goes much faster. It works really great for doing S3 fetches of S-state. And then the builders also I've got instructions in them as soon as it creates an S-state artifact locally, it'll mirror that up to S3. So yeah, that works pretty good because I try to keep those build VMs completely stateless. So they're always starting from scratch, and I always use ephemeral storage locally. Again, to keep costs down, because I didn't do that originally, and the charges for storage racked up big time.
Yeah,
AWS nickels and dimes you for everything.
Yeah, well, that's it's interesting. That's probably just a good practice anyway. For to keep things as stateless as possible, because then you don't have these golden machines that suddenly you don't know how you build it. So
right, or something, or cruft creeps in over time, and you don't. And then you have to wipe it, and then you're really stuck.
Right. Yeah.
So I'm sure you probably do something similar with Google Compute, or it's just AWS was the first thing that I learned. So actually worked for AWS for a very short stint as well, but that didn't have anything to do with my decision to use it. I was already a customer of theirs when I went to work for them. So.
Pretty cool. So anything that you're reading or watching or listening to that you'd like to recommend?
Well, I've for a while now I've been a computer history buff. I've got a bookshelf full of books on computer history. I don't know why. I don't think it's not nostalgia or anything. It's just I think I like history generally, just because if you don't know history, you're doomed to repeat it. So there's some podcasts I've listened to. The one that is currently active and is pretty good is called Advent of Computing. Sean Haas, he does a good job with that podcast. Covers a bunch of topics from the early days, and some fairly obscure ones too. So he actually recently had one on the Bliss language, which is the one I used back when I was doing VMS programming back in the early days, which was pretty cool. I also, as part of this, if you look on YouTube, you'll find the BBC series The Computer Program, which was the series they did in the 80s, back when the government there was making a big push they thought computer stuff was going to be their new industry, and that's when the BBC Micro came out and so forth. The Computer Program, though, is a great. It's not there are not that many episodes, but it's a great time capsule, and yet it's also a bit prescient, and
So
it's actually really well done.
it's the acorns, right? Which kind of precedes ARM, I guess. That's what it is.
Yeah, the program itself, though, they use the Acorn, I think, when for doing some demos. But the programs themselves cover various aspects of computing technology in a general way, and they have this journalist that comes in and does commentary every once in a while, who's you'll get a big laugh out of just how serious he is about this stuff. And so it's good. But they even talk about stuff like that we're talking about today, like AI. And, back then there was no internet, but some of the stuff that they talked about was widespread telecommunications, which still plays into stuff that we see today with social media and so forth. So it was, the first time I watched it was just recently, but it really stuck in my head. I wished I'd seen it earlier. But otherwise, books. I was just recently reading a book called How Things Are Made, which is about manufacturing. It's not a computer book, not a computer history book. It's about manufacturing. And if you work on products that, which a lot of us do in embedded land, and you're not already familiar with just how hard the supply chain problem is, and how many different people are involved in different places to actually get a product from concept to actually shipping to somebody's home or business. It's a good insight. It's a good introduction for folks that aren't that familiar, which, even I've been in this business for a while, there was stuff I still learned.
Sounds like a good resource. Yeah.
Yeah.
So you probably read The Innovators by Isaac Walter.
Oh yeah.
Yeah. Walter Isaacson.
Yep. I have some that are specific to particular, early home computing machines. I had a Commodore Amiga when I started out with an Apple II, and I went to Commodore Amiga. So I've got some books that are both specialized in just those platforms. But there's a book on Digital Equipment Corporation I have. Some are just general. Some are just curiosities. I have this book about some Canadian personal computer that was done in the 70s that I'd never heard of before. I have a book on the Leo, which was which was the Lions company in Britain that does tea shops. They developed a computer. Because they needed the data processing capability. So and that actually became a thing there. So it's just a lot of interesting stuff. Probably my favorite book, though, is a book by Jean Jennings Bartik, who was one of the women that worked on the ENIAC. The quote unquote first electronic computer. So she was one of the programmers. The book is called Pioneer Programmer, and it's a collection of stories by her. It's an autobiographical, and she's a riot. She's very funny. She has some hard things to say about people like John von Neumann and Grace Hopper that you get a laugh out of if you know anything about computer history. I'm not sure it's in print anymore. The copy I bought maybe 10 years ago now, and probably wasn't really popular, but it was. But if you can get your hands on it, it's definitely worth a read if you're at all interested in the early days of programming and getting the perspective of somebody that wasn't wasn't one of the heralded and lauded group of people that are considered the inventors of this industry.
Yeah.
Yeah, that's great. One of the neat things about this podcast is we always get some really interesting, or we sometimes get some really interesting book recommendations way off the beaten path. So one recommendation that was made a couple episodes back was on a book about Forth. So I started reading that book, and it's been really interesting. I need to finish it, but it's definitely not a mainstream book, but there's a lot of interesting things to learn.
Forth is a language that I've known about, but I've never had an opportunity to play with it because it's never come up in anything that I've ever worked on. I know people who do, and they swear by it. It's almost like a religion to them because for some reason, maybe that's a little bit afraid to go anywhere near it because I didn't want to get stuck.
Yeah. So this book, it kind of enables you to live vicariously, in the Forth, and you don't really have to do it. So that's kind of the neat part about the book. I don't know. It's just an interesting experience. So.
Yeah, there are folks that just swear by it though.
Yeah.
Almost as bad as Lisp.
So any advice for the young people?
Oh, well, you asked me that last time too, and I came up with something off the top of my head that, there's I think, I did think about it a little bit this time, and I think my advice, and I'm not sure why I thought of this other than I think sometimes some of the hype that comes out of Silicon Valley about the new thing being the greatest thing ever gets to me. And having lived through the dot-com bubble and numerous other hype cycles for new technologies coming out of the Valley, is just don't get caught in that hype vortex. It's fine to have an interest and think it's cool and want to work on cool stuff. But I've known people that have chased that kind of thing from cycle to cycle, different things each time, and it's like this never-ending treadmill of ups and downs that can be really exhausting. If that's the kind of thing you thrive on, go for it. But, be my guest. But if don't. What I've seen, certainly going through the dot-com bubble, was people that they bet their lives on the ever-growing internet phenomenon in the 90s, and when the bubble burst, they lost their shirts, and that's not a good thing either.
Yeah.
So just say, be skeptical about stuff like that. Always good to go in with your eyes open and understanding that it's never going to be as good as the marketing guys tell you. And it could take a long time to get there too. There was stuff I was working on back at the turn of the millennium, late 90s, early 2000s, around home networking and what we would call today Internet of Things, that died on the vine back in those days, but now are commonplace. So sometimes it just takes time, and being in the right spot on the technology curve.
Yeah, I mean, that's so well said. People are talking about AI these days so much that, it started a long time ago, the 50s and 60s. So every decade there was some work, and, famous AI winter and things, like they were ahead of the curve, behind the curve, whatever it was. But yeah, it's so well said.
I mean, I took AI courses when I was going to college. And,
I did too. Fuzzy
that was
logic.
A long time ago. And I thought it was a fad then. So, yeah, it's actually not that much different today than, at least in terms of basic principles, than it was then, other than we just have a lot more computing power to throw at the problems that make it seem like it works better, which, great, we can do that.
Yes. Thanks for your time today, Matt.
Yeah. Sure. Thanks for spending time.
Yeah. Appreciate your thoughts, Matt, and taking the time with us again. So
yeah, happy to talk to you guys anytime.
if you have any comments or feedback, let us know. Thank you.